All right, we are live, so thank you for joining us today for this live demonstration on CIP safety. My name is Jack Wheatley, and I'm the product manager at NHP for all safety components. And on my right here, I have Daniel Nathanson. Dan, can you say hi to the room?
I can. Hi, everyone. So my name is Daniel Nathanson. I'm commercial engineer for automation and safety. I'm also TUV Rhineland certified functional safety engineer. So happy to be here and helping present with the webinar. And yes, we're live, so please accept stuff ups with good grace.
No, I love it. Thanks for being on board. And on my left here, I've got Stefan Stainwall. Stefan, can you say hi to everyone in the room?
Hello, everyone. My name is Stefan Stainwall. I'm the technology specialist for safety and sensing at NHP. I'm also a functional safety technician qualified by TUV Rhineland. And I'm excited to be here and showcase to you what we have in terms of CIP safety.
Perfect. Thanks. I'm glad to have you on board, Stefan. So before we get stuck into today's presentation, I just want to firstly acknowledge the lands that we're standing on, which is the Wurundjeri people. We pay our respects to their elders, past, present, and emerging, and also pay our respects to any First Nations people on the call today. So without further ado, let's have a look at our agenda for today's webinar. So firstly, we'll discuss what actually is CIP safety. We'll then go into what products incorporate that CIP safety technology. We'll then look at a CIP Safety Light Curtain demo, which is new to our business and currently in every state and New Zealand. We'll then go through an add-on profile and what that looks like when you're programming it in Studio 5000. And then, of course, we'll close out with some questions. So if you do have any questions throughout the webinar, of course, put them into the chat. And if we do get an opportunity during the presentation, we'll address them. But otherwise, we'll come to them at the end and then answer anything that you guys might want to know further about. So yeah, without further ado, guys, let's get into it. And Dan, why don't you start by telling us what actually is CIP safety?
It's a very good question, Jack, because that is why we're here. So I suppose the first thing you should probably know about CIP safety is, okay, what is CIP? So let's just go have a look at it. First slide. So CIP stands for the Common Industrial Protocol. So this is a communications protocol stack, which is primarily used by a lot of the Rockwell automation products. It's been developed by the ODVA. So what CIP effectively is, it's a structure of the way that the data is transmitted between devices in an industrial automation network. So it's an object-oriented type of communication stack. So it's mainly, well, I suppose it's got classes, instances of classes. So you'll have a different class for a sensor, for a light curtain in this case, for a drive, for a PLC. And then within those instances of classes, you have services, which is what you use to I suppose, read the data and also write to the device. And there's also different types of connections, implicit, explicit. I mean, I can go on all day about this sort of thing.
We haven't got all day.
We haven't got all day. We've only got a limited amount of time as well. And so with CIP, there's different flavors depending on the type of application that you're using. There's a few that are here on the slide deck that probably a few of our viewers may have seen before. So there's CIP Sync and CIP Motion. These are mainly used for most applications that require very, very tight timing between devices that need to coordinate with each other. So we're talking like robotics and a lot of machines might use these profiles. CIP Security and CIP Energy are a few others. And then there's CIP Safety, which is what we're talking about today. Love it. Okay, so well, as I mentioned, so CIP Safety is a flavor of CIP. It's built on top of the rest of the CIP communication stack, but this is primarily for machine safety applications. Now, the reason why we have the machine safety part of this CIP protocol is to ensure that we have, appropriate data integrity, because, we've got safety devices which are operating over a network. We need to ensure that the data that's coming from the devices and going into the PLCs is safe and that we can trust it. So CIP Safety Protocol is independently certified by TUV Rhineland as well. It ensures that the safety rating, I guess, is incorporated in the devices and not necessarily on the networking media which is going between them. So, CIP Safety can operate over various different types of media. So I'm talking, EtherNet cables, copper, over fiber as well. And it also allows you to have a mix of standard devices and other protocols operating on that exact same network, not just safety devices. And because it's completely agnostic to the type of network that you're using, it allows you to have all sorts of different types of network topologies. So things like, we've got star topology, linear, device level ring, and other sorts of redundant media types.
So I guess just before we move on, just to clarify, in case anyone's unaware, the DLR network, what does that actually mean? Do you want to just give a quick explanation?
Yeah, DLR, device level ring. So it's, well, there's actually an image of it there on the slide. So it's having all of your devices connected together in a ring. It ensures that if the cable breaks or you have a device failed halfway inside the ring, the communication can still operate on the other side. Yeah, so it's primarily used. It is primarily used in a lot of CIP networks, not just CIP Safety. Standard devices use it as well.
Yeah, cool. Well, I guess we've heard about what CIP Safety is, but what are the advantages as far as for an installer? Like, why would we actually go to a CIP Safety network? Why wouldn't we just go to the typical hardwired solution?
Yep, that's a very good question, actually. So yeah, hardwired solutions still exist, and they have their place as well. So typically with a hardwired installation, you're limited by the complexity of your safety system, and also the fact that you've got hardwired devices going everywhere. There's a lot of cabling requirements that go into it. So you've got 4 cores going out to your device, for your dual channel signals and all sorts of other stuff, and then trying to develop a very complex safety system with multiple devices. It can become, I suppose, a little bit difficult when we're getting to that, and you're also limited by the amount of distance that you can have between devices too. So you don't necessarily want to have to run several hundred meters worth of dual channel cabling, and there's also issues with with a lot of high risk safety applications. You need to take into account things like short circuit faults that might occur on the cabling, cross channel faults. So there's all sorts of things that you have to look for when you're dealing with your traditional hardwired system. So the advantage of moving towards a networked option with CIP Safety is that, well, of course, you can run these things over longer distances. You can do 100 meters of copper Ethernet. You could do several kilometers of fiber if you wanted to. So if your devices are geographically spaced quite a fair bit, having them networked is quite ideal. The other thing as well is that a lot of the safety integrity, as I said, is built into the protocol. So you don't necessarily have to worry about risks with your network media getting short circuit faults or induced voltages or any of that other sort of stuff, because the protocol doesn't care what it travels along. It's the end devices which are safety rated.
Yeah, nice. I guess that's all well and good. Then I guess the number one question no doubt everyone's asking or thinking, Dan, is what actually makes CIP Safety safe?
Yeah, okay. There's a lot of detail that goes into the CIP Safety protocol that, frankly, we just don't have the time to talk about the details. But what I will go through is some of the fundamental aspects of what makes CIP Safety safe. So you may have heard of the 3 Ds: duality, diversity, and diagnostics. These are incorporated into nearly every type of safety system, be it hardwired or in communication space, which is what we're dealing with. So what do we mean by duality in terms of CIP Safety? Well, what it means is that the data that gets transmitted in that CIP Safety packet is duplicated. So if one half of the packet is malformed or doesn't make it in, there's the second half. The devices can also determine whether or not that data is I suppose, appropriate or is the correct data, because it needs to see both sets. So it's a dual channel redundancy, but it's built into the one packet. You've also got diversity. So when the data is sent, half of it is sent completely inverted. So now I said you've got the 2 different sets of data that come through. Imagine, you've got 1010, the inverted version of that is 0101. And so what's happening is it needs to see not only the first set of data and the second set of data, but it also needs to see the second set of data is completely flipped. If there's a 1 or a 0 that's in the wrong spot, it knows that there's a problem, and then someone needs to go address that fault. And then, of course, there's the diagnostics. So part of having this whole dual channel architecture and being able to have this diversity, this is all incorporated into the diagnostics. But what you'll probably notice from the slide as well is that most of the data packet in CIP Safety is dedicated to diagnostics. You've got cyclic redundancy checks, you've got dual data, you've got the diverse data. The actual data that's useful is only a tiny fragment of that data packet. The rest of it is to ensure that it is completely safe and is has its full integrity.
Yep. Got it. Yeah, I guess a lot of information, and obviously we can't go into too much detail given our time constraints, but you mentioned ODVA earlier. Do you want to just give us a quick overview of what that is and if people want to explore that a bit more?
Yeah, so the ODVA is a body for developing communication protocols. It's almost like a standards body. Yeah. I know someone's going to test me, and then of course we're live, so Open Device Standard Association, I believe. If I'm wrong, please don't flame me. But yeah, so ODVA is the body that developed the CIP protocol. And so CIP is not necessarily stuff that operates over Ethernet, but they've also got ControlNet and DeviceNet under the same banner. And it's all the same data structure, it's just operating over different forms of media. So DeviceNet, for example, is over CAN bus, whereas Ethernet IP is SIP over Ethernet media.
Yeah. No, that's good. A good point too, because it is a great useful tool if anyone wants to look online. It's obviously you can Google that ODVA, and they've got some great resources on there as well. As obviously we can help. But yeah, thanks Dan. Really appreciate that.
That's all right. Right over to you.
So as you can tell, Dan is our technical contact when it comes to SIP safety and safety in general. So if you do have any questions, of course, reach out through your local rep, and we can pass them back to Dan, and we can answer and help wherever we can.
Absolutely.
Yeah, so I think at this point, we'll probably look at what kind of products can we use with this SIP safety technology. So I'll come around, and you're probably all wondering, there's a whole heap of product on the table here. So of course, like all good safety networks, you need to start with a safety controller. Now, you'll notice that there's a red orientation around the side with a little guard master man, and that is to stipulate that it is a safety rated controller. Obviously, Alan Bradley. On top of that, you can also have some safety I/O. This might be in cabinet, in field, but again, you can tell clearly from the red coloring that this is a safety rated I/O module. So when we talk about what products can we incorporate with this technology, I'm jumping ahead of myself there, Stefan.
That's all right, Jack.
So we've got here a PowerFlex 755 drive. So we do have those in multiple sizes, but all our drives, our VSD drives, do incorporate that SIP safety technology. And I guess the biggest feature which Dan mentioned is they can be daisy chained just with a single Ethernet cable coming in and out. Put that up there. Now, the next device I've got here is a multifunction access box, commonly known as the MAB. Now, quite clearly, this is for full body access into any guarded area. Again, you'll notice that we've got 2 Ethernet ports to go link and daisy chain those in and out. We sell a lot of these and see a lot of them installed in the timber industry. You'll also see it's just got a single power input. Now, on the flip side, you can actually order these as a hardwired unit, and that's a 19-pin cable, just to give you a bit of perspective on what that looks like wiring 19 pins into an I/O block, comparable to a single Ethernet cable coming in and out. So another product we have is an encoder. So again, you can quite clearly see the red coloring stipulates that it's safety rated. And then looking on the back side, you can see we've got the 2 incoming and outgoing Ethernet ports. So again, daisy chain, as many as you like. And then we've just got a single power input plug just hanging on there to obviously power each individual device. But hollow shaft or solid shaft, all of those encoders do incorporate that SIP safety when they're the 843 ES models. So next we've got our scanner. Now you might ask, there's a lot of safety scanners out there. Do they all incorporate it? No, it's quite clearly the red stipulating here that this one is safety rated. And then if I turn it on the back, just our single Ethernet in and out, and again, a power input. But this will operate and work like any laser scanner, but obviously having that single Ethernet port to be able to access an add-on profile in the Studio 5000 environment, which is the Alan Bradley software, will just make that installation and programming quite a simple process. Now, the main part of our show today is the light curtain demo, which obviously we're going to use to demonstrate a bit later on what that SIP technology looks like. So our light curtains just plug directly into, I'll put that down, it's looking a bit awkward, but they plug directly into this Ethernet block. So what does that Ethernet block do? You'll have your input receiver and transmitter plugged straight into here, as well as 2 Ethernet ports to again daisy chain if you require, and then just a single power input. So I'll let Stefan talk about the Ethernet and the light curtains themselves a bit more in depth when we go into our demo here, but I will just remind and touch on that we do have these demos available in every state across the country, as well as having one available in New Zealand. So if you do want to have a look at, particularly the SIP light curtains, we can bring that to site and do a bit of a training session one-on-one with your team or with you guys individually. Might move this out of the way for you, Stefan.
Right. Once again, good morning, everyone, and thank you, Jack. So before we get into the detail of the light curtains, I'd first like to go through and set up some fundamentals or set up some context for this. Traditionally, whenever we have our light curtains, we'd have several outputs from the light curtains. These could be your safe-rated OSSEs, your muting signals, your mute-dependent overrides, your power, it could have your photoelectric sensors, and it could have your reset and your restart buttons. So in total, we're looking at definitely more than 4 inputs being consumed by your input card. Now, these inputs behave in a binary fashion, which means it's either on or it's either off. So there alone, your diagnostics that you're going to receive are limited to whether it's on or off. Now, however, this also consumes space in your cabinet. So there's limited diagnostics, and it consumes space in your cabinet. What's the other elephant in the room that we have? Those 6 to 8 cores of cable have to be dragged along in a multi-core fashion up to your light curtains. Now, this could run from a couple of meters to tens of meters, right? And therefore, what you're creating is 6 to 8 points of failure. You can have cross-channel faulting, you can have faults to 24 volts, ground faults, or you can have electromagnetic interference between your cords of cable as well. Now, how we combat this is as Jack alluded to before, what we've introduced now is the CIP Safety over Ethernet block. What this does is it takes those 6 cores of cable and it takes your input cards out, and we have an on-machine device that allows you to connect your light curtains to them. Now, I'll go into the detail of this in a little bit, but just to give you an idea of what benefits you do have is that your OSSD signals, your muting signals, your start reset are all encapsulated into a CIP safety data packet. This is a classic example of using both safety and standard signaling in your single data packet. This way, what we can do is we're going from a predictive type of maintenance diagnostics through an on-demand maintenance diagnostics. Now, I want you to keep that in mind because later down the line, I will show you how all of that happens. So I'm not going to talk too much about the architecture. Instead, I'm going to show you the architecture. For this, what I'm going to do is I'm going to get my trusty minions, Jack and Dan.
We're the minions, are we, Stefan?
You're the minions.
Got it. I'm the camera guy. At least we know our place.
You should know your place. Good. Well done, Jack. So I'm going to move this out of the way. And while Dan gets the camera ready, so what we're going to do is we're going to demonstrate what I've just spoken about. So something key that I mentioned was your safety OSSD signals. All those smart cookies online might be asking that question right now. Now, what we do is we've got, Dan, I'm assuming the screen is now shared. This one, can you confirm that? Brilliant. All right, so we've got our receiver to absorb the receiver's signals coming in. We've got the transmitter to provide power to our transmitter. We've got power to the device itself. And we've also got links to connect our Ethernet cables, right? Now, one thing you would notice is we've got link 1 and link 2. I'm going to echo on what Daniel said before. Link 1 and link 2 allows us to have our light curtains in a linear, a star, or a device level ring topology. Imagine a ring, imagine your device on the ring. What's the benefit of this? Is that if one of your devices go off, it doesn't affect the rest of your devices.
Hey, Stefan, that's pretty cool, but why haven't we got that plugged in today?
Sure. Today, I'm using this as a node in a star formulation. As you can see, it still works as per requirement. However, in my full demonstration that I generally do to my customers, I've got a multifunction access box, a laser scanner, and also a guard master safety relays, all connected up to this in a device level ring fashion. Now, one other thing that a lot of my clients have issues with is the alignment of light curtains. So I'm gonna get Jack to help me out here.
Minion 1?
Minion 1,
Minion number
correct. All right. So sometimes I get a call, Stefan, these light curtains are not working. And I go to them and I ask, okay, what's going on? I don't know. And then 9 out of 10 times it's the alignment going wrong. So what we've done in the past, what we have is we have an alignment device that snaps onto your light curtain. This can be specific to a certain type of light curtain, and a specific person needs to have this, which means we need someone who knows how to use it to be on site. I'm gonna show you guys how this works with our light curtains.
So Daniel, when you're focusing on just the screen over there, you should see a hand with a finger pointing. I'm going to get Jack to hover around this optical button. This optical button will then emit a laser alignment aid.
Yeah, go on, press it.
Yep, you want to press it?
There we go. There's a laser.
Cool. And Daniel, can I get you to place your hand and show everyone where these lasers are? All right.
There we go.
So we can see Dan's wonderful hand over there.
One
thing, very manicured, Dan.
Very manicured,
nice.
yeah. What you would notice is the beam intensities of these change, which means the radius of these beams change. Now, ideally, what we want to get, I want to make note of a couple of things before we go. I want you to, Jack, could you please show them the less than or greater than signs, please, on the light curtain?
Oh, that'd be these guys over here, the
Yep,
green ones.
correct. So I want you to place your focus on those guys. Now they're off because we're misaligned. And I also want you to place your focus on the triangle with the star there. So what we're trying to achieve here is we want the beam with the highest intensity to come between the triangle and flash on the star. So Jack, can I please get you to start aligning the light curtains?
Yep, so there you go.
All right.
Align them there.
Now what we can see is the less than or greater than the less than or greater than signs. They are both illuminated in green. This implies that the top half and the bottom half of your light curtains are now aligned.
One thing I might point out as well, Stefan, as well, is that those greater than or equal to signs, they're on both light curtains. So it's not just on the transmitter or on the receiver, it's on both. So you look at both sticks in order to get that. So just to prove on the transmitter, it's those two just there. So we can tell looking at both ends of the light curtain if they're aligned.
Thanks, Dan. Thanks for adding that in. So now we've aligned our light curtains. We've also shown you how to connect everything up. Now you might be wondering, we've got these muting sensors here. Stefan's a big liar. He's told me that we don't use any I/O on my PLC. Correct. Dan, can I please get you to go to the reverse and show the muting distribution block?
Yep, that's
the muting distribution block, again, is an on-machine device. It's IP rated, which we use to connect our muting sensors and also to showcase whatever outputs we have. Now, let me just show you. I've got this configured for muting fashion, but since we've broken the light curtains, it's not going to demonstrate. However, we can see that the device is being output from that. So what I've done is I've induced a fault by creating a wrong muting sequence, and we can see our muting light flash right now. All of this is done programmatically. I'm not going to take too much time. I am going to go straight onto our Studio 5000 environment. Thank you very much, Dan and Jack. I do appreciate your support here.
Props. You'll see soon.
All right. So for those of you who are unaware of Studio 5000, Studio 5000 is a software program that we use to program our compact guard logics, our guard logics, and in some sense, our CR30s as well as a network device. So Studio 5000, I'm going to go through the architecture first, and I'm going to get Harrison to go to the slide where we've got the Studio 5000 banner as well. Now, one thing I will go through the architecture of this. So we've got the controller organizer. This is where we've got our controller tags, our programs, our alarms, our motion axes, and our Ethernet devices, and those on the backplane. Now, if you do notice, on our tasks, we have a safety task and a main task. Now, standards stipulate that we need to have a safety and standard tasks separately. Why is this, you might ask? Your standard task must be, we must have the ability to amend your standard task. We can have timing changes, we can have parameter changes, we can also have device changes. Maybe we're moving from standard photoelectric device to an IO-link device. Then we'd have to change our standard parameters. This happens more frequently. Safety, on the other hand, once we've done our risk assessments and once we've established our system, we should not change it. Changing it will compromise our safety. And we can't ensure that everything is done.
Probably something else I might mention as well, Stefan. Some of our astute viewers are probably noticing on the safety task there's a little 20 millisecond thing next to it. I might even take the opportunity to explain that.
Go for it.
So the main task in a PLC is typically continuous. It's got the lowest priority. So it will run as long as it can, whereas the safety task is a periodic task. It will operate every 20 milliseconds, regardless of what else is going on. It is the highest priority task inside the safety PLC. So it ensures and it guarantees that everything that's happening in the safety program happens every 20 milliseconds and pauses everything else. because the safety is the most fundamental aspect of this thing.
Exactly.
That's right.
And to add to what Dan said, what I will also go on to is, because safety is the most fundamental task, another thing that we have is your safety program is password protected, and you need to make sure that only certain people know this password. And secondly, every safety device, whether on the backplane or on your Ethernet node, is given something called a safety network number. This number is unique to each device. And if you replace, say for instance, your Ethernet block with a new Ethernet block, you need to reset ownership, which means you need to unlock your safety program, reset ownership, and then put the machine back into its working state.
Yeah, the reason for this actually is so that, you might have a CIP safety network with multiple different PLCs and controllers on there, different types of I/O. What you don't want to have happen is one PLC telling your I/O to do something, whereas the other PLC hasn't. So ensuring that the I/O has an owner, in this case, which is tied into the safety network number, it means that you can have these mixed devices on your network and not have to worry about, who owns what, and you ensure basically that this I/O is only controlled by this controller, and that's it.
Exactly. Yeah. Thanks, Dan. So we've now clarified the differences between the standard and the safety program, and I hope it's all clear so far. Next, we're going to go on to the topic of discussion for today, which is the 450L Ethernet block. Now, as you can see, our Ethernet block is on our Ethernet tree. So I've got this connected directly to my compact guard logics. That is just at the bottom over here. And what we've got here is our Ethernet tree. As you can see, my light curtains are now active. And if I double click on this, this is what opens up. As with any other Ethernet device, we set our IP addresses, we configure what type of series they are, and we also need to configure what type of light curtains they are. I've taken the liberty of installing that on profile and configuring this for the purposes of today's demonstration. I'm going to focus on what a lot of us truly value. Let's start with something called beam intensity. Traditionally, when, say, a contractor calls us from your plant, you are going to wonder, oh no, these light curtains definitely go under. What's going on? Why are they tripping falsely? This is where beam intensity comes into play. Say, for instance, you've got a network system and your light curtains are on Ethernet. You'd log on using your Studio 5000, you'd go online, and then you'd get a live demonstration of this. Now, what I'm going to do is I'm going to get Daniel to place his hand first in there.
Yep.
Right?
There you go.
Now, as you can see, some beams would be going black. The reason as to why this goes black is because Daniel's fingers are now blocking these lenses. So this is a live view of what's coming in.
Yeah, you'll also see 4 black bars because I got 4 fingers in the beams. This light curtain in particular is actually the finger safe.
Correct. Yep. Exactly.
Finger safe resolution.
So Daniel, if you take your hand out, and now I'm going to demonstrate a classic situation that we all have. Hey, maintenance manager, my light curtains are tripping. I don't know what's going on. This is when we all hit our heads. Daniel is going to demonstrate to us beam intensity changing. All right. So I want you to pay close attention to your light curtains. Did you see how those red beams have now become orange? And if we look at our legend over here, it says that red is high intensity, orange is medium intensity. Yeah. Now, in a case where we have a low intensity, these are the typical beams that would go into a false state or erroneously trip. Then what we'll tell our contractor, hey, have you checked if there's dust on the lens? Secondly, have you realigned the light curtains? Wait, I don't have a realignment tool. That's fine. Place your finger over the optical button and you can realign your light curtains.
One thing that we could probably mention as well, this is supposing really important in terms of integration. So, I mean, one of the main reasons why we want to go for a CIP safety network is for integration. Everything's on the same network. We can bring it up into our SCADA. We can put it into our maintenance system so we can generate work orders. This is a classic example of where, most photo optic devices like, laser scanners, sensors, light curtains in this particular fashion, they suffer from dust and dirt and all sorts of things from getting on the lenses. And I'm sure a lot of us can relate. Yep. You have to go out and clean it very regularly depending on the environment. So when we're talking about integrating this thing into a larger system, you can basically pull out the data from all of the beam intensities, and you can set up a work order to say that, okay, when the beam intensity starts to go below a certain threshold, generate the work order, someone goes out and cleans it. This avoids the need of having to have periodic maintenance. Exactly. If you have the predictive maintenance aspect, you can find that the workforce can be better utilized in other areas. Yeah.
So why not create on-demand maintenance than predictive maintenance? You'd rather maintain more crucial parts of your business than have to focus on the little things. Let the little things take care of themselves by creating tags or alarms that can be raised to your maintenance and then create a work order.
Yep.
So now we've looked at beam intensity, which is one of the key things that we spoke about, and that's what I spoke about in the beginning as well. The next thing, what we're going to look at is the beam status. Now, some of you might be questioning the difference between beam status and beam intensity. The CIP Safety over Ethernet light curtains, when combined with its add-on profile, has the ability to have 4 independent configurations, which means we can have the light curtain doing separate functions. Now, what you can see here is our light curtain having a separate function. Right now, we're in a function of muting. Say, for instance, I want to change this. Then, using my add-on profile, and my controller tags, I still can change this. I'm going to go on to the configuration. You might be asking, so you can do muting, blanking, and partial muting all together. So I'm going to go on and show you how it's done. I'm going to click on the configuration tab over here. So as you can see on the top left, just over here, we've got configuration 0, configuration 1, 2, and 3, 4 configurations. I'm going to go through some of the functionality you can have here and some of the functionality that we commonly used. Blanking. I'm confident everyone knows what blanking is. We've got fixed blanking and we've got floating blanking. Floating blanking is ideally used in coilers, uncoilers, and recoilers, or in an area where we've got a constant feed product going through. So why do we need safety on this? A constant feed of product is going out. We don't want people putting their hands in or people actually coming into the hazardous area. So that's where we would use a floating blanking mechanism. Now with the floating blanking, we're able to set the size and we can have multiple objects or single objects going through. Next, let's go on to muting. So when we talk about muting is the automatic suspension of your light guard for a period of until your sensors are active for a periodic time. So traditionally with your muting, once your muting sensors are activated, your full light curtain will be suspended, or it'll think that there is an actual product going through. During this time, say for instance, we've got a low profile pallet going through. This means that someone can come into the light curtain from the outside. This is an unsafe situation. So we do have. Yeah.
Oh, well, what I was going to say is, it's a typical example of sending empty pallets through a set of light curtains. If you're muting the light curtains, what's to stop someone from standing on the pallet and pretending that they're a product?
Exactly.
So for things like palletizers, this is a bit of a problem there, because the way that these muting needs to be set up in the standards is you need to make sure that the access to the hazardous area is still blocked off while muting is active. So, sending an empty pallet through, you're not exactly fulfilling that requirement.
Spot on. Yeah. And that's why with our add-on profile, we have the ability to have partial muting. Through partial muting, what we're allowing is only a certain profile of product to go through. This could, in a sense, be a check as well for you to ensure that all your pallets are of a certain size and they go through safely. Next, the question is, I showed you guys the muting distribution block at the back. This is where I connect my sensors to. How do we do this? So this is through our inputs and outputs tab. So our outputs tab have several pins which we can output data from and we can take in data from. Pin 5 and 6 have been assigned and dedicated for my muting sensors. That's what you can see over here. I've set my muting sensor 1 and muting sensor 2. This can also have an optional manual restart just in there as well. Now, next thing what I've done here is I've programmed some of my pins to have muting active, muting error, and so on and so forth. So all of this information is encapsulated within the add-on profile and converted over from your add-on profile via CIP Safety over Ethernet through to your Ethernet block, your light curtain, and then absorbs the outputs as well.
Hey, Stefan. I'm sure a lot of people are looking at this and thinking, why do we have multiple configurations there? Could you go through those for us?
Yeah, 100%. So multiple configurations, as I explained a little while before, is, say for instance, we have a single output line with 4 product groups going through. One product group might be of a short size. One product group might have a specific size, and the other a different size. So I'll explain it to you over here, right? So for this example, I'm going to get Jack to place his hand just in the light curtain, and now you can see only part of the light, the black lenses of the light curtain. That's what's blocked. Now, say for instance, right, the next situation, we have a higher type of pallet going through. So which means we'll have twice the length going through. So now what we've seen is we've got two sizes of product going through, but we want muting. But we also want to ensure that the muting is done for that specific product. Then what do? We go to our configurations tab and we enable our partial muting here. This way, we know that only one type of product is going through. So what I'm saying here is 4 production lines all converging into one, which then allows us to have different product profiles at different times. This is also a check to ensure the right product is going through.
Yeah, so you can change the configuration, programmatically as well. So
correct.
It's not a simple case of having to load a new configuration in the PLC every single time. You've got all 4 configurations set up, and then you just basically, write a tag, turn it on, and then that configuration will go to the light curtain.
Correct, Daniel. And that's all done. As you can see, what I've pulled up here is the controller tags that are innate to the light curtain, and this comes with the add-on profile. So what you would do is you go to active configuration, you'd assign it a different type of configuration, and now what we'd see is this bit over here should change to a different configuration.
Yeah, there you go. It's gone to a 1. You
Yep.
typed in a 1, so it's on config number 1 now.
Exactly. So let's go to config number 3 just as a proof of concept, and now we'll have a look here. We've got config number 3 come up. So these are the benefits that you can get with light curtains. Now I am coming to the end of my time. So I'm going to summarize what we have in our light curtains. Our light curtains, I'm going to stop sharing my screen and let's go back to presentation view. Let's go, sorry. Alrighty, so our light curtains, what we enable you to do is we reduce your wiring and your cost significantly. We encapsulate both your safety and your standard communication packets into an Ethernet framework. And we have much more data. As Daniel and I spoke, we spoke about on-demand maintenance as opposed to predictive maintenance. So with that, I will conclude my session of today's presentation, and I'll hand it back to Jack and Daniel.
Perfect. Thanks, Stefan. Really good, really great presentation. I love the way you broke it down. But yeah, we're definitely seeing quite a lot of positive feedback from the industry just by seeing that add-on profile and configuration in the light curtains themselves. So just another feature of the CIP Safety platform.
100%. The add-on profile is something people really enjoy using, and they love the visualization you get into it and how much time they would save on this. Everyone's all about uptime, and this is exactly what we're delivering with this. So I'm not sure if we're going to go into questions next.
Yeah, I think so. But so again, I'll just reinforce that we do have these light curtain demonstrations available across our business. That's in every state and region across Australia, and then of course one in New Zealand. So if you do want to know more, or you want to get a bit more of an in-depth view, and that can be any CIP safety device, we can actually come out and demonstrate that to your plant, team, yourself individually. Of course, just reach out through your local sales rep, or obviously you'll be able to contact us via this web at the conclusion of this webinar.
Stuff. All right, question time, I guess.
Let's do questions.
It looks like we've already had a couple of questions.
We've had quite a few come through.
What have we got?
Let's see what we have.
Let's just filter some of the
live webinar. Yeah, give us a second. We're just pulling them up, guys. So full screen that. I should be able to see it.
Yep, that might help.
Perfect. Yeah, great question. So I've got one here from Mark. I might direct this to both you guys. Feel free to answer. So, do you need to have a safety PLC to use CIP safety devices, or can they be interconnected directly to each other?
I might actually grab that question if it's all right. Actually, you know what? Safety PLCs, you can take that one, Stefan.
Sure,
go for it.
As I mentioned at the start, it is good number.
Yeah,
as I mentioned at the start, because we're dealing with a safety device, we need to have a safety PLC. Now, what are the safety PLCs that allow this? In our range, we have the the compact guard logics and the guard logics PLCs that allow us to have these safety devices.
Well, we got one there.
Just the one that Jack showed us before.
One at the start.
Yes, exactly. So, yeah, we've got a few more questions.
Sure, yeah, we do. This one's probably more relevant for you, Dan, but CIP safety, Wi-Fi 4G?
Yeah, okay.
Possible?
Is that a question? Yes, it is possible. Yeah, okay, this is my bread and butter. Yeah, so CIP Safety is the protocol, and as I was mentioning, it's completely agnostic to the type of media that it's running across. So you can run it over copper, run it over fiber, and yes, you can run it over wireless. In fact, there's a really good white paper which has been published by the ODVA. You can probably just Google this, CIP Safety Wireless, and you'll find it. But that gives you a lot of good guidelines as to how to implement a wireless system using CIP Safety. So yeah, of course, I mean, the data packets will happily operate over Wi-Fi, LTE, 4G, 5G, LoRaWAN, or whatever it's called. There's a few different wireless technologies, and it'll happily work. But there are some things you need to consider. So, things like distances, attenuation of the signal, things in the way, trees, trucks, whatnot. Because the thing is with CIP Safety, it's meant to revert to the safe state in the event that there's any faults in the packets. So wireless can be particularly problematic because you can get dropped packets, due to reflections. You can get malformed packets. There's all sorts of issues that can happen, which, for non-safety applications, the device just sends another packet and it'll accept it. But with CIP Safety, if it misses a certain number of packets in a certain time frame, it basically thinks that safety device has gone offline, bring everything to a safe state. Or if it receives a few malformed packets in sequence, kill everything, go to the safe state. So it's just about bringing, ensuring that integrity is there. And wireless has got some issues in that respect, but having said that, there's advantages to having wireless. If you've got remote pumping stations, where you don't want to have to trench 2 kilometers worth of Ethernet or fiber, you can basically set up a directional Wi-Fi antenna and receiver and do it that way. So yeah, absolutely, you can check out that white paper.
Yeah, and to add to Daniel, we actually had an application where we had a crane and we had a shuttle going between these 2 points. So we actually had a compact guard logics, 2 compact guard logics at one point and at the shuttle. And using our Microsoft radios, we actually communicated CIP Safety over Ethernet, and they've been using that for a while now. So that's a classic example of this.
Yeah, actually, that is a good example because cranes and gantries, they're normally controlled by pendant control stations, that kind of thing, or you need to walk along with the crane as it does things. And the safety standards are quite strict on what you can and can't have operating over a cableless control. And when it comes to safety, if you read the standard, if anyone here reads standards, there are certain requirements of the protocol, but CIP Safety ticks those boxes anyway.
Exactly.
Yep.
Cool.
So I've got one here. It's probably for yourself, Stefan, particularly about the light curtains. And they've asked, Ethernet and hardwired light curtains, do they use the same transmitter and receiver, or are they different types? So traditional light curtains clearly have 2 different ones.
Yeah. That's a brilliant question for whoever put that in. So I'll take this opportunity to actually discuss this. So now our light curtains function on a transceiver technology. All right, so I'm going to disconnect this for the purposes of this demonstration.
This is what happens when you get questions that are completely,
So our transceivers work, our light curtains work on a transceiver type technology, which means this is both your sender and your receiver. How is this configured? Through the plug-in modules, right? What does this mean on stocking point of view? You only stock 1 spare. And this does not break because this is generally shielded from most of your issues. So this can be a standard. You can have muting functionality, blanking functionality, reduced resolution. You can also have universal that will work as both as a sender and a receiver. So say, for instance, today, you've got your standard light curtain set up, and tomorrow someone comes and says, all right, we need more data from our light curtains. That's fine. You keep your transceiver stick the same. You change one of your plugins to the Ethernet plugin, which has your IP address set up on the side here. And then all you need to do is integrate it into your existing compact guard logics or guard logics PLC. And then, as I showed you guys before, you can get all that information out. So hopefully that answers that question. And Daniel, do you want to add something?
Oh no, I was just going to make a quip. That I like the people who say that they've got hardwired today, they'll go Ethernet tomorrow, because those are the people who are watching this webinar today.
Exactly. Cool. And
well, I've got one that's almost on topic, but Kant has asked, can CIP Safety running over Ethernet be affected by Ethernet switch loading or VLANing?
Yes, it can. So yeah, VLANs. So depending on how complex your network requirements are, yes, there will be some requirements for quality of service and VLAN impacts and all that kind of thing. So it is still a good idea to try and segment as much of your
critical infrastructure using VLANs and having quality of service set up in all your routers. This sort of goes a bit beyond the scope of what we're talking about today, but yeah, you treat it as though, it's any other type of data packet. Try and segment your networks as best you can to get the traffic routed as quickly and, as deterministically as possible. Yeah, that's actually a really, really good question. Yeah, the having a networked solution as opposed to hardwired, while it does resolve a lot of problems that can exist with hardwired, it does expose a few other considerations for networked media. So,
at a greater benefit, of course.
Yeah, exactly. That's a great question, actually. That caught me off guard, so thanks for that one.
Nice. That's what we're here for. So another one, I'm just going to keep working through them. So if you do have questions, keep putting them in the chat. If we do run out of time, we'll get to them later and we can contact you guys. But one's come through and they're asking, can it be used, can the SIP safety technology be used on PowerFlex? PowerFlex drives, and the answer is yes, obviously, but can it incorporate on the PowerFlex 525 series? Again, the answer is no.
Not on the 525. So the 527s can have SIP safety over Ethernet. The 525s, if you want to have, safe talk off applications, that's a hardwired option. But typically speaking, if you want to go for a SIP safety over Ethernet, there's the 527 or the 750 series through the add-on cards.
So on the back of that, Michael's actually asked, can we confirm if VSD drives can meet a Cat 4 or is it a Cat 3 safety only rating?
Depends on the drive. Can I leave it at that?
Yeah. Complex. Depends.
Yes. A single device is generally, you can't assign a safety category to it. It's all dependent on the architecture. So can you use a drive in a category 4 system? You can. You may also require some line contactors to disconnect as well. If you're dealing with performance levels and not necessarily with categories, which is the way things are going, you can absolutely get PLD or PLE using just the drive, no additional contactors. Again, depends on the model, depends on the risk assessment and everything else. But yeah, treat it as a whole system, not necessarily with the product itself.
Yeah, like it. So Antonio's asked, what demand or loading does a SIP safety system have on the processor, on your safety processor that is? So is it something that people should be considering, or is it not? Is it insignificant to the system?
Well, it's that's actually not a bad question though. I mean, as far as loading is concerned, depending on your controller, there'll be a certain number of Ethernet nodes that you can add to it. So you treat a SIP safety device as you would any other SIP device. It consumes a connection. So yeah, if you're using a fairly low-end compact guard logics, there'll be a limited number of connections that you can have. So your SIP safety network is then, I suppose, has to be smaller, or you might segment it to have certain sections of your machine operating with their own dedicated guard logics controller. But I mean, as far as CPU loading is concerned, typically the safety task itself doesn't have a lot going in it because it's mostly just on-off stuff. Yeah. So you'll find though that the packets come in fairly quickly, and generally speaking, there's not that much detriment in having the safety task in there.
Can you also see this via integrated architecture builder through the network load?
Yeah, you can actually. Yeah. So yeah, if you use IAB, Integrated Architecture Builder, which is a really, really good software package, yeah, you can design SIP safety networks using IAB, and you can see what the loading looks like in there and determine whether or not you need to upgrade your controller or do whatever you have to. Yeah.
Exactly. And for those of you who already use it, the EtherNet light curtains and the laser scanners are already on IAB. If you update your software, you can see that, and then you can put it into your system and understand your network loading as well. But also keep in mind, it also depends on what your program structure is, isn't that?
Yeah, that's right. Yeah.
So Andre's asked, are there any safety laser distance sensors that are not just a laser scanner themselves? So,
as part of our product range?
No, we don't have any, Andre. Michael's followed up and asked if we're having any issues with components. Like everyone, we are having issues, but we're working through those. Got one here from Stephen Clark, friendly name from our Vic sales team. Given the network capability of safety devices, has there been a return on investment study of an integrated architecture solution versus a hardwired solution, re the time saving and the electrical engineering hours required?
Yeah, they have actually. So there are white papers available on the ODVA. So you can find them either on the ODVA website, you can Google it, or even on the Rockwell Literature Library. So yeah, there have been studies done on it to basically evaluate the performance and time saving.
Nice. So Mark's actually asked if we could demonstrate the SIP safety technology via a VSD with the STO. Obviously not right now, Mark, but if you do reach out to your local sales rep or even through our customer care, we'll be able to organise someone to come on site and actually show you what that looks like.
Yeah, actually, Stefan, when you go out and do the demonstrations for light curtains, you mentioned you're also taking the MAB lockbox, scanner, all sort of things. So yeah, I mean, of course, if you want us to demonstrate a particular type of product, if we have the sample of it with us, yeah, sure, we could go and demonstrate that.
And feel free to reach out to your local representative, and I'm sure each safety technology specialist are well equipped with all these devices, and we're more than happy to come and have a discussion with you and truly show you how everything is done, including a little bit of assistance on sample code as well.
Yeah, you're not sure that they're well equipped. They are well equipped.
They are well equipped. Okay, there we
go. Good pickup. David's asked in Studio 5000. What methods and restrictions do you have to transfer the information between safety tasks and your main task?
Yeah, so the tasks have to be separated. That is a requirement of the standard. Geez, I'm answering all the questions today. Geez, this isn't fair. Going between the standard task and the safety task, you can have shared tags that go between them. These are mapped safety tags. So you need to have a standard version of the tag and a safety version of the tag, and then you need to set up a mapping. But you have to be absolutely careful that if you're going to be doing this safety tag mapping, that any fault or unforeseen or a foreseen error that might accidentally turn the standard tag into a state that you don't want, it is going to be replicated in the safety task. So please be careful.
I think I'll add to what you said as well. So keep in mind, some of the tags that you do get from the add-on profile are standard tags as well.
Yeah.
And if you're going to map your safety tags, the general rule of thumb that I follow is never be able to write to it unless it's absolutely crucial, like changing your configuration or something.
Yeah.
So make sure whatever you do, your OSSDs cannot be written to, and I don't think you can, but always ensure that, keep in mind, there are standard tags in your add-on profile, and then there's just safety tags, which is your status.
Yeah, exactly.
Yeah.
So I mean, something like the light curtains, you'll have your fault status and your actually on-off status of the light curtains. They will be in your safety tags, but you'll also have standard tags like is the connection active? You'll have the diagnostic. You'll have fault codes, that kind of stuff. So
everything.
Yeah, depending on the device, you'll have a mix of standard and safety tags available too.
Yeah. Di has asked, are there any specific networking requirements to ensure that CIP safety requirements are met? The cabling and the switches that we use.
No, that's the beauty of it. Yeah. It's just the end devices. So you have your guard logics or your safety PLC. It has a network interface card built into it, which is safety rated. On the other end, you'll have your scanner or your light curtain with a network interface card built in. That's also been certified and tested to safety. Everything in between, it's a black channel. It doesn't actually matter. You can run it over industrial networking gear, commercial, residential if you really wanted to, even though I wouldn't recommend it. In fact, the protocol can be done over carrier pigeons probably if you want to hand write ones and zeros and send it in the mail. It's the protocol and the end devices are all that matters when it comes to a CIP safety network. Yeah.
So it almost leads into the next question here, which Murray's asked, and a term that pops up in safety over Ethernet is the black channel principle. He's asked if we can touch on this a bit, so I don't know if you want to...
No, that's what I was basically explaining. Yeah. I mean, I'll explain that again. So the black channel principle is, you have your end devices. They're the ones that you consider, and they need to be safety rated. They also need to meet certain standards for integrity. And then there's the protocol, which is CIP safety itself. The protocol is also safety rated, but what a black channel means is that everything between those two devices is a black box. You don't see what's in it. You don't care what's in it. And that's the whole principle of it, is that the protocol is what's safety rated. The protocol travels over whatever media, any sort of switches, routers, gateways, hubs, if you're that old. Doesn't actually matter. It's completely black. You put your blinkers on, you don't look at it.
So it's just the two devices at the end that needs to be able to encapsulate and decapsulate those.
Yeah, exactly. So one device needs to be safety rated to generate the CIP safety packet, and then the other device needs to be able to decode that. And then send the response. That's all that really matters in a black channel.
So I've got a quick one here. Amar's asked, what's the maximum size length light curtain that we offer? And that in 1950.
1950.
Correct.
And I think he had also asked the distances. So depending on the resolution, you can go from 10 meters width apart all the way to 16.2 meters apart, depending on the resolution you're after. But as I said before, contact your local rep, engage your safety technology specialist. and they'll be able to help you out a bit more.
Well, actually, in terms of the maximum height, remember you can cascade the light curtains as well. So you can have, a 1950 millimeter, and then you can cascade it to another 1950. You basically got 4 meters with light curtain.
That's a great point.
And it doesn't always have to be the same size, right? It can be a 1950 and a 150
exactly.
as well.
You can exactly.
Go nuts on it.
Anthony's asked one for you, Dan. You mentioned, I hope you don't mind answering these because you're on fire.
It's not personal. Okay.
Daniel, you mentioned malformed packets in sequence before a shutdown. How many before a shutdown?
That's configurable. Does that answer the question? It can be, basically you would specify how many packets and what kind of delay. This is done inside the safety PLC, which is also called a scanner in terms of EtherNet IP terms. You specify what kind of time delays between packets, how many you're looking for between you decide that the device isn't there. But you need to be careful with your settings because what that does, that impacts the response time of your entire safety system. Yeah. So if your safety PLC all of a sudden sees a malformed packet, it's now waiting for the second malformed packet to come through. And now it's waiting for the third, and then it's waiting for the fourth. Meanwhile, someone's walking through the hazardous area and could potentially get hurt. Yeah. So it is a fine-tuning exercise. You need to make sure that the amount of delay in diagnostics is balanced by the response time of your safety system. Yeah.
So we still have quite a few questions. We'll probably finish up with this one now, and then we will get back to you guys and send a document that's answering quite clearly everything that's come through. But Matthew's asked, is CIP Safety vendor-specific? Obviously, we're talking Allen Bradley here today. Or is it widely available on open protocol?
Open. Many other devices in the market can opt to use CIP Safety for their devices, not necessarily just the Allen Bradley Rockwell.
Benefits, I think, not using it are truly envisioned when you use.
The point though is that you might not necessarily have an add-on profile for that device. So there might be a lot more integrating that you need to do in your safety PLC or in your SCADA or whatever to handle this third-party vendor. But no, CIP Safety you can incorporate in any device of the network card, really. Yeah.
Perfect. Well, I think we're actually basically out of time, unfortunately, but it's actually been a really great discussion. And quite clearly, the industry is very interested in CIP Safety, still getting used to what that actually means, what it is, and what advantages it actually provides to businesses. So, again, we are more than happy to come on site and do further training, help you understand it and see the value that it can provide to your business, organisation, however you see it. So, my name's Jack Wheatley. I'm the product manager for the safety products at NHP. On my left, Stefan.
My name is Stefan Stainwall. I'm the technology specialist for Wheatley. So those of my customers who are online, obviously you guys more often. And Daniel?
Yep, Daniel Nathanson, commercial engineer for automation and safety. If you ever send through a technical question about safety, it usually ends up with me. So please, by all means, ask Stefan all the hard questions, and he'll have an attempt at answering them.
Exactly.
It's been a great session. So thanks very much for tuning in. We hope you enjoyed the live aspect. We wanted to provide a bit more of that live aspect that we provide to each individual customer. So, enjoy your day, and thank you very much for signing on.
Thanks, everyone. See you later. See you next time.